Today, we want to continue talking about integration by parts with even more integration by parts. In our list of things to do on the parts category, we've talked about the basic integration by parts. The integral of u dv is uv minus the integral of v du. We've talked about the multiple parts. This is where we differentiate down to zero. When we recognize that we're going to do parts multiple times for one integral, the multiple parts is when we differentiate u all the way down to zero. Sometimes this is referred to as a shoestring method, but shoes aren't strung that way. So I refuse to call it shoestring method. And then today we want to talk about the reversal. I normally just call this integrating by differentiating, but I use the in the first two. And so in true Hamaker-Schlemmer fashion, I had to call this the something or other. I didn't know who would recognize the Uno reverse card. So in the reversal, but the maneuver is we integrate by differentiating. Remember, in the integration by parts process, we decide on a u and a dv. And then we differentiate u and we integrate the dv. We differentiate one part and we integrate the other part. Let's take a look at an example. At this point, also, we have been conditioned to stick the polynomial in the derivative location. But we have to remember that the other rule that goes with this is that dv has to be something that we can integrate. So let's take a look at this example. A classic example, and usually the first example where we integrate by differentiating. So if we look at the integral of x cubed natural log of x to x, one of the parts is a polynomial with this x cubed, and the other part is natural log of x to x. Our normal training says that maybe we should make u the polynomial part so we can differentiate down to zero, but this leads to a problem immediately. If we make u equal to x cubed, then dv is natural log of x dx. And we immediately run into a problem because we do not know the antiderivative of natural log of x. So immediately we run into a problem. We don't know that the integral of natural log of x is x ln x minus x. We know the derivative of natural log of x is 1 over x, but we don't know the antiderivative of natural log of x. So we're going against our first rule of integration by parts. dv has got to be something that we can integrate. So this means we need to change our strategy. We don't know the antiderivative of natural log of x, so we'll change our strategy. The most direct thing we could do is just switch them. So our strategy is to just switch parts. We try something else. U is natural log of x. and dv will be x cubed to x. In the past, when we have done this with the polynomial in the dv location, we've integrated and things got bigger. But like we just said, the derivative of natural log of x is 1 over x. So the one extra x that we add on this side gets taken out by the 1 over x on the differentiation side. So it's all going to work out. Trust me, everything will be fine. So we chose our parts. We chose our givens. Next, we found the other two parts. Now we put together in the parts formula. So I'm going to have uv minus the integral of v times du. And now we can see how well everything has worked out. So in the secondary integral, we've got an x to the fourth times 1 over x. And because through differentiation, our natural log of x turned into a 1 over x, turned into a rational function, we can simplify our secondary integral. So we have a 1/4 x to the fourth natural log of x minus 1/4 the integral of x cubed to x. This is a cool trick. We have to look at one variation of this trick. We have to learn the integral of natural log of x. In this problem, the x cubed was there to be something. So we would have something that we integrate. But in the reversal, when we're integrating by differentiating, it might be that all we have for dv is dx. So let's look at our next example. The point of the previous problem was to emphasize that dv has to be an integral that we know. The point of this second one is that all we might have for the dv is the dx. So we know that I can't put the natural log of x into the dv location, because if we knew that, I wouldn't be doing parts. I would just be writing down x ln x minus x. But we don't know that yet. So we're going to do just like we did in the previous problem. U is natural log of x, and then dv will just be dx. So the point of this problem is sometimes all we have for dv is dx. The important thing is that you don't try to separate the natural log from the x. The natural log and the x are not two separate things that are combined by multiplication. It's natural log of x. That is one factor in your integral. Everything else happens like before. We take the derivative to find du. We integrate dv to find v. And then we can put together in the parts formula. So I have uv. I'm going to write it as vu because I want my polynomial to go first. So we put together in the parts formula just like before, and just like before, v times du cancels out one of the x's, or the du cancels out one of the x's from the v. So our secondary integral is going to be easier to deal with. We'll have an x ln x minus the integral of 1 dx. So we get x ln x minus x. The reason that this worked is that taking the derivative of natural log of x, turn it into a rational function. The derivative of this weirdo function, natural log of x, was a rational function. That's what kind of defines this Uno reverse card. And these are the situations that we're going to use this technique in. When we take the derivative of one of our factors and we end up with something that changes form, like a rational or a radical function, that's what these are all about. So going back up to this dramatic reversal. The big idea is that we are changing the form of one of our parts. Derivative of natural log of x is 1 over x. Transcendental functions derivative is a rational function. Other situations where this might happen. Okay, other situations where this will definitely happen to you on the homework. The derivative of tangent inverse is 1 over x squared plus 1. The derivative of sine inverse is 1 over the square root of 1 minus x squared. The other one you should know, I guess, for completeness, although I don't know if this one shows up on the homework. You should look up the integral of, or the derivative of secant inverse. I don't write this one down to make you go look it up. So the point of this particular technique is that one of our parts, when differentiating, changes its form. Any questions? Another thing to note, at this point in your mathematical career, you now know that the integral of natural log of x is x ln x minus x. You now know that. If on the next quiz I write down, I ask you to find the antiderivative of natural log of x, you just type x ln x minus x plus c. I'm even going to say show your calculations, and you're just going to type x ln x minus x plus c. And if anybody calls you on it, you just say, I remember it. I also don't, and then if you want to be snarky, you'd be like, oh, I also don't have to write down on paper what 7 times 8 is. It's just shit that I know now. So this is something that you know now. You get to use that knowledge. In fact, if you can see the pattern, if you can see the integral of natural log of x is x ln x minus x plus c, and you can see how it's going to work. With the x cubed integral of x cubed natural log of x, and write 1/4 x to the 4th natural log of x minus 1/16 x to the 4th plus c. If you want to demonstrate that you understand how this is going to work, when I ask for the integral of x to the 5th natural log of x dx, you just write down 1/6 x to the 6th natural log of x minus 1/36 x to the 6th plus c. And when someone says, aren't you supposed to show your calculations? You say, I did. I just recognize what's going on. I did those calculations. All I had to do was add 1 and square the results. I think I can handle that without writing everything down. That make sense? Yeah, for those of you who like show up in someone else's class, we do the integration by parts. And if you're a future Calc 2 teacher, it's like, oh no, you have to write the stuff down. You need to find another math teacher. Because where does it end? Now, if you're writing it down because you're copying it off of Wolfram Alpha, then you're being shitty. Not to anybody else but yourself, because you're like, oh, I don't want to know stuff. You're just literally taking the position, it's better to not know things, which is never correct. I mean, why would you think it's better to not know things and then spend all this time and money going to college to like know stuff? You know what I mean? It's fucking ridiculous. Students are like, I gotta find a way to not know stuff, but make it look like I know stuff. Some of you may notice that earlier we switched tactics on x cubed natural log of x dx because we didn't know the antiderivative of natural log of x. And some of you may be thinking, hang on a second, do we now know, now that we know the antiderivative of natural log of x, can we go back and redo that original problem, x cubed natural log of x, but with this knowledge? And the answer is 100%, you totally can. I wish you luck. In fact, you should. I'll put an exclamation point to make it seem like it's a really good idea. Hey, check it out. We can now go back to integral of x cubed natural log of x with natural log of x in the dv location. In fact, I am even going to give this my endorsement. This is a great idea because it will reveal another technique, another important. This is a great idea because it will reveal another cool technique that shows up in integration by parts. This would be number 4, the return of the original integral. This is why I love integration by parts. As a story, it has a twist on the story. There's the reversal. There's the return of the original. If you take the basic and include multiple parts, that can make one movie, and you end up with this trilogy of integration by parts. Because the basic and the multiple parts, that's one movie. The protagonist goes up against the boss with just the basic and gets the floor wiped with him. The boss just wipes the floor with the protagonist. Then the protagonist has to find the secret master to learn the secret technique defeating the first boss. That secret technique is multiple parts. Then they show up and the boss says, I will defeat you the same way as last time. X to the 4th times e to the 5x. And then the protagonist busts out differentiating down to 0. And then the boss goes, you should learn the secret technique. And then the boss loses, which we could tell by the runtime that was going to happen in this fight. Right? But then in the next movie, a new boss comes along. And the old technique doesn't work, right? The first thing, the protagonist sees an x cubed show up and is like, I will just differentiate that down to 0. And then the new boss is like, but what is the antiderivative of natural log of x? Defeated. He's got to go find another technique. See what I mean? It's like a whole story. I'm picturing a whole anime series, but combined with like being raised to watch movies in trilogies. So like 3 movies, but the style is definitely anime. So like the boss has like a real close up of his eyes, and then he like looks to the side. And then it makes it look like someone is moving, but really just the screen is flashing behind. You know what I'm talking about? You have to watch old animated series where it's just like one fixed picture that like comes onto the screen. It's like, but then the background is like flashing and moving, and then so it makes it look like this is much more dramatic, like the pen companies. Oh, I could be off camera. Then you realize nothing actually moved in that picture. It's just flashing lights. So we watched the reversal today. Now, normally what I do is just do this problem with dv equals natural log of x, but to see the return of the original, to see that happen, you have to go do this. That's the entry price. If you want to see this integrated with natural log of x, y'all have to do this. See what's happening. You have to take the role of the protagonist and get defeated by the mess that happens here. And then we'll find out if you're determined enough. To persevere through the next one. Any questions? How's everybody? Okay. I've always thought that calculus should be, I should punch this whole thing up a little bit by like making it like more of an action movie. Like instead of just me talking about calculus all the time, there should be like a fight scene or something like that. This is what I envisioned, by the way. This is what I envisioned. So what's going to happen is I'm here doing calculus, and then all of a sudden from the ceiling, because this is a false ceiling, it's perfect. You can hide ninjas up there. What'll happen is like little rope will drop down from the ceiling, and then it'll be close up of my eyes as I notice, because nothing gets by me. Right? I go, and my eyes like look over, and then one eyebrow goes up. This is why I want The Rock to portray me in the movie. Not because I look like The Rock. I mean, I'm not delusional, but he can do the eyebrow thing, and I can't. So what would happen is like the ropes come down, and I notice them out of the corner of my eye. No one else in the room has seen it happen yet. But the professor knows he's about to be attacked by ninjas. For what reason? It doesn't matter. This is an American movie. None of it has to make any fucking sense whatsoever. This is why The Fast and the Furious is the greatest movie franchise of all time. And so I'm like, oh, and so we'll see next is, and because it'll be close up on my eye and my eyebrows will do the thing, and I make some kind of grunting noise. And then all of a sudden, like a ninja shows up. It's like, ah, he's got a sword and stuff like that, but I've got a pen in my hand. So it's like, I fling the pen, and the pen like gets him in the eye. And so the next thing is like the ninja's like the next shot of the ninja. He doesn't have to move because it's an anime, right? And it's like this, and there's like blood spraying out like this. But it would be like delayed version where it hits him, and then he's going ah, and then like a second later, just like gout of blood. Right? You know what I'm talking about? Can you picture it? You know exactly what I'm talking about, don't you? If you don't watch the right movie. But anyway, he's like there for a second. And then even though this is a pen, it's like what, 10, like how many grams is this? See, no, this is why like washing machines is a perfectly acceptable unit of measurement, because no one knows how much a gram is anyway. Like what, 10 grams at most? Even though it's a 10-gram pen and like 150 pounds of ninja, I throw it so hard he gets knocked back out of the room. But that's not how like projectiles work, but okay. There's no physics in this classroom. So I'm like, oh. And then of course there's a bunch behind me. So I have to defend myself. And so I just grab like, and then it turns into a Jackie Chan skit where I just start throwing pens, right? Because there's these pens here. And I have 2 other pens, but for some reason, these are going to be on my belt. And I'm going to reach behind myself and pull out these 2 pens and like fling them. 2 other ninjas get pinned against the wall. And then it's like a whole fight scene. Can you picture it? I mean, wouldn't that make a better movie than just like calculus? Anyway. The Rock won't return my calls. Stupid restraining order. If you call the Rock again, and they'll come and arrest you, fine. What if I email him? The same thing, Leech, knock it off. Just kidding. I don't have a restraining order against me. Dwayne The Rock Johnson does not have a restraining order against me. It expired yesterday, so expect a call, Dwayne The Rock Johnson. I'm just kidding. It expired over the weekend. I gave him Sunday off. I'm just kidding. All right. So as an important exercise to get into this even more secret technique, you need to go back and do x cubed natural log of x with dv in the lnx spot. You're going to have to do something weird. I will give you a hint. I think in 7.2. Example 6. I think it's example 6 for an inspiration. All right. Let's summarize our techniques of integration. We've only had 2 so far, but we should maybe take a view, take a longer view. See some upcoming things, like Marvel, like the MCU, saying these are all the movies that we're going to be making. Someone said that there's going to be some MCU burnouts. People have been saying that there's going to be MCU burnout since like 2014. So maybe this time for sure. And then they're going to declare themselves correct. But you don't get to keep saying, it's like, well, the world is going to end on this day. No, okay, it's this day. Hang on, I forgot to carry the 2. It's this day. And then like the world actually ends, you don't get to say that. I called it, see? If every year you've been saying that the world is going to end this year. You don't get to do that for like 50 years in a row. Then when the world actually ends, saying, see, I called it. It's like, oh, no, you're just always saying that. It doesn't count. So if you're predicting MCU burnout and have been since 2014, it doesn't count anymore. You missed your shot. Should have saved it. So this is beyond this is techniques of integration beyond our basic techniques, like integral, add 1 to the exponent, divide by the exponent. That stuff's all automatic. These are the things where we might actually have to do something. Substitution. Parts. Having substitution in parts doesn't actually cover everything. It's not like product rule and chain rule, like derivatives. Product rule and chain rule covers everything. You've got all your derivatives. You got your basic derivatives, product rule, chain rule. You are done with differentiation. If I introduce some newfangled function, if I just tell you what the derivative is, you can now combine that function with anything else, and you know exactly, because you know exactly how differentiation works. You all have a complete picture of differentiation. Integration, not so much. We can't get away with just anti-product rule, anti-chain rule. There's all kinds of other stuff that we have to deal with. Is that how you spell shenanigans? I should know such an important official term of math. I just want to see if I can make anybody write down shenanigans in their official Caltoon notebook. So there's some algebraic stuff that we need to know to deal with rational and radical expressions. We've touched on this a little bit with our long division. But the things that will show up in this category are long division, complete the square, so completing the square is where you take ax squared plus bx plus c and write it in its vertex form. And everybody's favorite, partial fraction decomposition. We're going to spend an inordinate amount of time integrating rational functions and radical functions so that we can get experience with this long division, completing the square, and partial fraction decomposition. Now, partial fraction decomposition is an algebraic technique that you probably have not been taught. Because if you try to teach partial fraction decomposition in an algebra class, it usually leads to open revolt. So a long time ago, we said, you know what, we got to stop having these open revolts in our algebra classes. So let's like push off partial fraction decomposition until it comes up in Calc 2. And usually this discussion comes up like immediately after a revolution in some high school algebra class. It's like, well, yeah, they're only high schoolers, but they're scrappy and they got a lot of energy. So maybe let's put this off. Mostly we want to look at these three things because it limits quite a bit what we need to be able to do with integrating rational functions. So I like integrating rational functions. It's fun. And then what's going to be your favorite technique? Trigonometric substitution. This is always everybody's favorite. So in trigonometric substitution, we're going to learn these three different cases of trigonometric substitution. The technique always works the same, but we want to see that it breaks into three cases. And this is all still very much related to this rational radical function business with this trigonometric substitution. Notice the three cases that we're dealing with is the tangent case, the sine case, and the secant case. More importantly, what determines the case that you're in? A squared plus x squared. So that's where we're just adding the x squared and a squared. The sine case is a squared minus x squared, where secant case is the opposite of that, x squared minus a squared. So we have three cases for trigonometric substitution. What we're going to notice in 3 and 4, our algebraic shenanigans and our trigonometric substitution, is that we become really focused on this quadratic business. And it raises the question, why do we stop at quadratic? So notice that one of the techniques here is long division. That's just generic rational function business. Partial fraction decomposition, that's also generic rational function business. But then I have complete the square, which is something that only applies to quadratic functions. And it really comes down to partial fraction decomposition. This is why we stop caring at quadratics. This partial fraction decomposition is really the reason that we can stop caring at quadratics. We care about linear stuff. We care about quadratic stuff. After that, it's just linear and quadratic. Any questions? I just want you to have a quick roadmap of the things that you're going to be dealing with. What you're going to be doing now is practicing substitution and parts. Substitution is a technique that at this point in your career, you are trying to make automatic. Your goal is to be handed a problem, an integral in substitution, and just write down the answer. Figure out what the inside is going to be. Figure out any constant factors that are going to show up. When you have an x dx, but the derivative of the inside is a 2x, you know that you're going to have a 1/2 out at the end. If you're integrating something to the third power, you're going to have a 1/4 from the integration. So that's what you're practicing. Substitution, you're working on making that automatic. Parts, you're going to work on your multiple parts technique. You're going to work on your integrating by differentiating technique. And some of you are going to put natural log in the wrong spot, knowing that the integral of natural log of x is x ln x minus x. And you're going to see the crazy stuff that happens there. All right, that's going to do it for today. Tomorrow we'll pick one of these to work on. That's it for today. I'll see y'all tomorrow. Everybody have a good day, and thanks for playing.